We're going to let f of x equal x minus 1 squared, g of x is equal to e to the negative 2x, and h of x is going to equal 1 plus the natural log of 1 minus 2x. We're going to find the linearizations of f, g, and h at when a is equal to 0. And what do you notice and how do you explain what happened? So, the first thing is we're going to call this L of f of x. And we know it's going to be f of 0 plus f prime of 0 times x minus 0. And we also know that our function f of x is equal to x minus 1 squared. And we know that the derivative of this function is going to equal 2 times x minus 1 to the power of 1 times the derivative of x, which is 1. And now we want to find out what is f of 0. Well, that 0 minus 1 squared, negative 1 squared is positive 1. And then f prime of 0 is going to equal 2 times 0 minus 1, which is negative 2. And so therefore L f of x is going to equal 1 plus negative 2 times x minus 0. And therefore that is going to equal 1 minus 2x. Okay, now we want to find the linearization of g of x, which again is going to be, in this case here, is going to equal g of 0 plus g prime of 0 times x minus 0. So we know that that's step number 1. We know that g of x is equal to e to the negative 2x. And g prime of x is going to equal e to the negative 2x times the derivative of negative 2x, which is negative 2. So therefore, this is negative 2e to the negative 2x. Now we want to find g of 0. Well, that's e to the negative 2 times 0. And e to the 0 is going to equal 1. G prime of 0 is going to equal negative 2 times e to the negative 2 times 0, which is equal to negative 2 times 1, which is equal to negative 2. And so therefore Lg of x is going to equal g of 0, which is 1, plus g prime of 0, which is negative 2 times x minus 0. So Lg of x is going to equal 1 minus 2x. Okay, now we want to find LH of x, where we have h of 0 plus h prime of 0 times x minus 0. We know that h of x is equal to 1 plus the natural log of 1 minus 2x. And the derivative of this, well, we know that the derivative of 1 is going to give us 0. And we know that the derivative of natural log of 1 minus 2x is 1 over 1 minus 2x times the derivative of what's inside. The derivative of negative 2x is negative 2. So we get negative 2 over 1 minus 2x. So now we want to find h of 0. So that's going to equal 1 plus the natural log of 1 minus 2 times 0. that equals 1 plus the natural log of 1. 1 plus 0 is going to equal 1. So h of 0 is going to equal 1. And then h prime of 0 is going to equal negative 2 over 1 minus 2 times 0, which is negative 2 over 1, which is equal to negative 2. So we have LH of x. We know that h of 0 is 1 plus h prime of 0 is negative 2 times x minus 0. And so LH of x is going to equal 1 minus 2x. Okay, so what do we notice and how do you explain what happened? Well, what we notice is that LF is equal to LG, which is equal to LH. Okay, and why does this happen? Well, this happens because F, G, and H have the same function values and the same derivative values at a equals 0. Okay, now in part B it says graph F, G, and H and their linear approximations, and then for which function is the linear approximation best and for which is it worst, and then explain. So we're going to graph these functions on Desmos. So the first function we have is x minus 1, and that's squared. And we have e to the negative 2x. And then we have 1 plus the natural log of 1 minus 2x. And then the linearization function is the same for all of them, so it's going to be 1 minus 2x. Now, let's make sure we have a nice readable viewing rectangle. So we're going to go, let's say, negative 0.5 to positive 0.5. We'll go to 0, 2. Okay, so let's take a look at this function here. Okay, so we know that f is the black function. I believe g is the red. And then the blue is h, and the green represents the linear function. So the linear approximation appears to be the best for the function f, since it is closer to f for a larger domain, than it is to G and H. The approximation looks worse for H since H is moving away from L faster than F and G do.